Hey everybody, Daniel here from Basement Tech. This video is going to be a little bit out of sequence, but while I had the monitoring project taken apart to add a few more components to this board, I thought I would do a quick video. This is the board, mostly a breakout board, that gets the pins from the Raspberry Pi to something where I can connect wires more easily and readily. These blue things here are just screw terminals. You screw down the screw and it kind of pinches the wire in there, so that's very convenient for just bare wires coming from the various components. And this connector in the middle just ends up via ribbon cable connected to the Raspberry Pi. I'm using this diagram here that's readily available on the web. I'm sure you've all seen it. And that's the connector that is on the Raspberry Pi, is also running down the middle of this schematic, and is this black connector on this board. In terms of technique, I really like proto boards. I've shown you this proto board here, which is a really convenient one from Adafruit. It has power buses on left and right, and it's what I used for the remote monitoring module, the one that's ESP8266 based. This one here doesn't have any rails or any of the pins connected. It's just plated through holes, but it provides a really nice substrate on which to build circuits. I don't have too many components on here and very few active components, but this provides a really nice way to add those components and get the wires from the Pi to these terminals. In terms of technique, I'm going to flip it over and you can see. First at the bottom is that amplifier module that I've mentioned before, 3.5 watt stereo amplifier, Class D amplifier, very efficient. It gets its power from this green screw terminal separately, 12 volts, and no, actually 5 volts I think. I'll have to check. But then it gets the audio from the 1/8 inch connector here that goes right over to the Raspberry Pi as well. And on the back side, as I said, it's just soldering point to point. I bought a spool of this, which is not solder, it's actually wire, just plated, zinc plated, I guess, wire. That's really convenient for making point-to-point connections like this. You can see occasionally I just tack down the longer runs onto one of those plated through holes. In other cases, it's just a direct connection. And finally, in third cases, I just take advantage of the leads that are on the components. You do see a couple of active components. These over here are MOSFETs, and I just decided to put those on for loads which might be a little bit heavier in current. For example, I have that really loud fire system annunciator that I think I'm going to use. That draws, I don't know, small fraction of an amp. And I just provided one extra because I don't know what I'm going to do with that one. I didn't want to have to come back and work on this board again. So that's this NTD4815, and you see the specs there, 30 volts at 6 amps. But you also see the footnote that the way I've used it in this circuit, it's limited a bit because of the gate drive, the 3.3 volt gate drive, but it's going to be more than adequate for this application. And then over here, I have a little LED base light that I'm going to use for to indicate when the local key switch for putting the system in auto has been overridden. And I didn't want to be limited on the current, so I just put another small MOSFET over there, about a 1 amp MOSFET, the ZVN4306A. So you see that on the board kind of right over here. And then I decided, and I'm not sure exactly why, but it felt more comfortable to do external pull-ups rather than use the pull-ups that are inside the Raspberry Pi, all maybe in an effort to move any current handling out of the Pi and keep it more cool running. So there you have it, that breakout board that goes between the Pi and all of the respective components that make up the system on a proto board with soldered point-to-point wiring on the back. I'll post this schematic on the GitHub, but you can get a quick view of it here. I hope this video was helpful. If you like it, press like. If you really like it and want to see videos on the rest of the system, definitely subscribe. Well, I wanted to do just a quick epilogue. I installed the board, and before I put the ribbon cable back on and obscure all the connections, you can get an idea of how it fits into the system. Remember, under that outlet is the solid state relay. Over there we have the motion detector and speakers hiding over here, which connect to that amplifier. Finally, over here, the newest addition is this, oops, kind of upside down, but you get the idea. A key switch for turning it into auto mode, and that LED to indicate that the key switch's desires have been overridden remotely.